All right, today we're going to talk about two different solutions. Okay, the first one we're going to talk about is what's called a standard solution. The second is what we're going to talk about is called a diluted solution or a dilute solution. The key thing that you need to know about the word standard solution is that it has a known concentration. So if I tell you that that solution has been standardized, it is exactly known the concentration of that solution. Now, there's a way that they can actually approach this on the AP exam. They can actually ask you to explain in a laboratory method of exactly how you would create this stuff. Okay, and we're actually going to do that in a lab. We're going to probably do it one day next week. We may end up doing it on Thursday if I can find all the materials. It just kind of depends on the time. It shouldn't take long. As long as I can get through solution and dilution, we're going to do both of them at the same time. So this is where you will have to use words and sentences to explain this. This could be a lab question with a response. Here's an example of how you're going to do it. The first thing you're going to understand is you're going to create solutions by doing what? If I asked you to make sweet tea, how would you do it? Okay, you would take a certain amount of sugar and you would pour it into water, and what would you do? You would not. Do you put the sugar in before you boil the water? There you go. Okay, so let's start there. First of all, you got to have hot water, and then you pour the sugar into the hot water, right? Now, whenever you make sweet tea, do you have an exact massed out amount of sugar that you use? No, you just fill up a cup, dump it in there, right? Okay. So, or if you take the bag. So it's not a very scientific process. So when we're creating solutions, we need an exact concentration of certain solutions to make certain reactions happen, to do certain labs. So when you're making sweet tea, it's just like, well, the more sugar put in, the sweeter it'll be. The less I put in, the less sweet it'll be. But could we create a specific concentration of sweet tea if we desired? Yeah, absolutely. We could create a 1 molar or a half a molar or a 0.75 molar, depending upon how much solution we use. So here's an example of some words we could use. Mass out the solid as accurately as possible. First of all, how are you going to mass it out? Physically, how would you do it? A digital scale. You would basically have a digital scale, you'd have a weigh boat, and you'd pour it on there. What is as accurately as possible? How could you rephrase that? If I told you I need 5.00 grams, you mass out exactly 5.00 grams, right? So we need to be as accurate, and I want you to add this word right here, and exact. Because if you do the stoichiometry, can you determine exactly how many grams of something that you need? Yeah, that's what that worksheet that y'all did on Friday was. It gave you a certain number of moles, it gave you a certain concentration, it gave you a certain volume, and then it asked you to potentially calculate how much mass you would have needed. Okay? We're going to place it in a volumetric flask. Why volumetric flask? Okay? Does everybody know what a volumetric flask looks like? Okay, it's got a really skinny neck, and then it bows out of the bottom, and then it's got that. I mean, I know obviously that's a little crooked, okay? But here's the important about a volumetric flask. So let's just pretend that this is a 500... Nick, what is so immaturely funny about that? It's a flask, Nick. Okay? It's a flask. Now, the important thing about a volumetric flask is that right here on the neck, it's got a line. Okay, and this line represents the 500 milliliter mark. So if you filled this up to that mark, would it be exactly 500 milliliters? Yes. Now, what are two other types of glassware that we could use to get 500 milliliters? There's two others. Okay, a beaker, right? If you've got a 500 milliliter graduated cylinder, it's like this big. But it's possible, so we're not going to talk about that. We're going to talk about something easier to use. Okay, very good. An Erlenmeyer flask. Now, the difference in an Erlenmeyer is that it kind of looks like this, okay? And it's got an opening here at the top. So, no, it just kind of goes up like a cone, but it doesn't point. Sir? Different tools are used for different types of equipment. All right, basically it simplifies things a lot easier for us. So, if I asked you to get 500 milliliters, and let's just pretend that this right here was the 500 milliliter mark, and this right here was the 500 milliliter mark. Of the three, which one would be the easiest to find 500 milliliters? No, the easiest. Why? Very good. So the less surface area we have to distinguish the volume, the easier of a job it is. Because you agree that making the volume of water right here, that it could be off by several milliliters if you don't do it properly. But this one, it's so skinny that you can pretty much make the 500 milliliter mark almost exactly perfect. And that's a lot of water, okay, or a lot of solution. But it's really easy to determine because the neck is so skinny. And the Erlenmeyer flask, again, is easier than the beaker, but it still can be a challenge just because of how wide the neck would be. So, again, we're going to mass it out exact and accurately as possible. We're going to put it in a volumetric flask, and we're going to add enough distilled water. Now, let's pause there. Why does it need to be distilled water? Do what? Yeah, you can't put pure water. You need just H2O because it's going to dissolve a little bit differently. To dissolve the solid, now, notice how this is said. Add enough distilled water to do what first? To dissolve it. And then add the water, filling it to the mark on the flask. Now, why did I put enough water in to dissolve and then fill it up? Okay, is it easier to dissolve it in less water or more water? Less, because you can control it a little bit easier. So if you take a volumetric flask and you fill the water up, let's just say we've got some purple solid down here in the bottom. Okay, and I take the water and I fill it up until about right here. What can you do to dissolve it? Swirl it, right? But if you fill it up to this point, is it going to be a lot harder to dissolve it? Yeah, you put it just enough in to start breaking it down and start breaking it up. So again, if you dump solid into 1 liter of water, you are neglecting the space the solid will occupy. So that's another concept. What if you fill it up to the 500 milliliter mark and then put the solid in? It's going to add more space to it, right? So that's another reason that we want to make sure that we dissolve it before we fill it up. It's because you're actually going to take up some space with that solid, okay? Now, does a clump of solid or the dissolved particles take up, or which one takes up more space, the clump or the dissolved particles? The clump. So we need to dissolve it first before we end up filling it up, right? So that's another reason. So here's exactly what we do. We take the weighed amount of solid, you put it in the volumetric flask. Notice what happens. They filled it about halfway up, and what did they do to the solution, or the solid? Stirred it to dissolve it. Okay? What is happening to the color as you move left to right? Why is it getting lighter? Okay? You're diluting the concentration of that solid. So when you put in just half of the water, you're going to get a more concentrated or less concentrated solution than the very end. It's more concentrated in the beginning, right? So you're going to have that stronger color. Right? So again, and that's what's going to happen to these. So steps involved in preparing a standard solution. A massed amount of substance, which is the solute, and in the volumetric flask, and a small quantity of water is added. The solid is dissolved in the water by gently swirling the flask. And then notice in parentheses what we put. Okay? With the stopper in place. That's not a very good color. With the stopper in place. So right here we've got a stopper. There are 2 reasons that could be important. What's one? The obvious reason. Make sure nothing gets out of it. We want to make sure that everything that we put in stays in there. What's another reason? Fumes, very good. Could gases be produced during reactions? Yes, and we want to make sure that no gases are released whenever you're going on. Because if there are, you can trap them and you can put them in the fume hood and let them go. So there are reasons. Now, do you have to do it every time? No, but sometimes it helps if you do the solution. Yes, sir. Yeah. All right. Now, so more water is added until the level on the solution is reached, the mark etched on the glass. If you actually take an Erlenmeyer flask, and I'll get one in just a second, I'll pass it around, but you can actually feel in some of the glassware where it's etched into it, so you can actually feel it. A lot of times it is just a white mark on the line, on the glass, okay? So here's another way to do it. It's just kind of detailing the picture. You take the solid, you pour it in. Now, could you already have some water in there? Sure, either way works. You can do this either way. You can put water in and then pour it in. You can pour the solid in and then put the water on top of it. Swirl it. What's a better way to do this? With a stopper in? No, you definitely don't want to do it with a stick. You want to swirl it around. That's the whole purpose of using the volumetric. And then we're going to add water to what point? Okay. Can y'all see that there is a line faintly right there? Okay. Also, there's another point of emphasis that I want to make on this particular picture. At what point do you know it's 500 milliliters? Very good. Not read. Read. Read the bottom of the meniscus. Meniscus. No. Never. Why? It is. No, it really is meniscus. Meniscus. So, here's how we can get a little more specific in the details. And again, the more details you add, the better off your answer is going to be. So, if we can add little small details, it's going to make it a lot better. So, number one, this is a requirement. State the compound. If you do not state what you are weighing, it is automatically probably going to be wrong. State the compound in which you are using. Okay? And then obviously, not only do you want to state I'm using sodium chloride, but I'm using 5.00 grams of sodium chloride. That should be a minimum as well. So we're going to state the exact mass of the solid being weighed. Determine from the math. Okay. Now, when I say math, I mean one word. And when I say math in chemistry, that ugly word that y'all don't like. Okay. Another way to fancy it up is to state the size of the volumetric flask. Why would that be important? You're specific. Here's how I want you to think about this. I want you to write it as detailed as if you were giving this to someone else for them to perform the experiment. If you just said, put some sodium chloride in a piece of glass and swirl it around, it's probably not going to be the best. State the exact compound and formula, tell them exactly how much, and tell them the size of the glassware to use again. So make sure you state if it's a liter or if it's 500, if it's 250, make sure you tell them. State whether you are mixing it with hot distilled water. First of all, why hot? It dissolves faster, it's more efficient. Okay? Does it have to be hot? No, it can be warm. Do you have to even include the word hot? No, it's just making it more fancy. You may want to mention the word stir or swirl. If I were you, I would go with swirl. It's a real nice fancy word. If the mass is less, here's what we're going to do. We actually want to cross this out. So take a red marker and completely cross this whole part out. I did that a few years ago, and I kind of come to the conclusion that's really not a good idea. Okay. Basically state that you want to put enough water in there to do what? To dissolve the solid, then fill it up. So really, I need to change that. It doesn't matter about the mass. Let's just go ahead and put enough water in there to dissolve the solid. Instead, we'll fill the volumetric flask the rest of the way up to the mark. So these are just ways to fancy up your answer that are very good ways to make sure that you give enough details. So state the compound, state the mass, state the size of the flask, state that it's hot distilled water. Talk about how you're going to swirl it to mix it, and actually the whole part about where you're going to put in enough water to dissolve should go before the swirling part. Okay? Again, those are just nice, simple ways to do it. So we've already done this, right? We've already solved this math part. So here's what I want you to do. If you're on your iPad, I want you to add a page. Okay, I want you to add a page. And I want you to write how you would do this. How would you make this solution? Okay? And that could be like part of it. Blah, 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 blah. I need you to explain how you would make this solution. That could be like part B. Part A would be to solve for the concentration. The next part would be to explain how you would create this solution in a lab setting. So I want you to actually pretend writing how you would perform this. Do what? That's you. You have to determine that based off of the question. All right, so this is kind of how I wrote it. This is kind of how I said it, and I added a bunch of things to make it sound just right. So if you read this, you could actually recreate this in a lab, but I left a few blanks in there. Place blank grams of blank into a blank milliliter volumetric flask. If you started out this way in every single solution creating explanation, could it work? Every single one of them. That is a blanket statement that you can create in every single one of your reasonings. Place blank grams of blank into a blank milliliter volumetric flask. But according to this question, how many grams? Okay, go ahead, Peyton. You know, that's a great question. I haven't even thought about that. Yeah, all right. So you know what? Y'all actually kind of got me on that one. So, um, yeah. There we go. Is that a little better? Thank you. That actually, y'all got me on that one. If you want to take a picture of it, maybe a really good idea. And this is basically what you can do to add this into any type of discussion you ever do. This is a template. This is a format. You just put. All right. What else is wrong? What's wrong with that? Does it have to be completely? And swirl the solute until it is. Wow. Till it. You didn't see that. It's one of those days. It's Monday. Anything else that I've grammatically screwed up? I'm writing it like below my hip. Yeah, absolutely. You can add that in there. Finally fill the volumetric flask up to the until the meniscus reaches the line on the flask. And again, this is what we're doing. We're perfecting it. We're making it better. I would use practically because if you tried to swirl something until it was completely dissolved, you may be spending hours doing it. So practically is just like if you're making sweet tea. Are you ever going to get every single piece of sugar molecule to dissolve to the point where you can't see it? No. So when I say practically, I'm kind of giving you this leeway that, you know what, that looks good enough, even though I still see some stuff floating around, right? Okay. So that's kind of it gives you some leniency. So mass out blank grams of blank and place it into a blank milliliter volumetric flask. That's probably the best way to start it. So my apologies in the beginning. Add enough hot distilled water to dissolve the solute. Swirl the solute until it is practically dissolved. And again, you can say completely, but practically gives you that room for error. Finally, fill the volumetric flask until the meniscus reaches the line on the neck. One more thing I messed up on. The line. The line on the neck. This will create a blank molar solution. Excuse me, a blank molar of solution. Okay, so let's fill in these blanks for this question. How many grams? All right, 11 and a half of what? NaOH solid. Do you agree it'd be a good idea to throw that solid in there? Okay, and place it into a what volumetric flask? Okay, this says a 1.5 liter. Can you, and again, this is kind of that weird one. In this case, could you drop the milliliters and go with a liter? I would. You can put 1,500 milliliter, but it's a lot easier to say 1.5 liter. Add enough hot distilled water to dissolve the solute, blah, 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 blah. What would this create? 192 molar NaOH solution. What is that particular solution specifically? Which is a strong base. Very good.